Okay, in this video we're going to look at defining variables and then just some basic point plotting, and then we'll look at graphing scattergrams or scatterplots, okay, which are just a fancy way of saying graphing points when you have a context of a word problem. Okay, so first of all we have a variable. Okay, a variable is a symbol, usually a letter, that represents a quantity that may change. Okay, so in the word variable is varies. So varies meaning change. Okay, so a variable is just a quantity that may change. For example, let T represent time, H represent height, or P represent profit. So in example 1, suppose T represents a number of years since 2005. Explain the meaning of each. Okay, so T equals 0 would mean that if T is 0, that's the number of years since 2005. So all that T equals 0 would mean would represent the year 2005. T equals 1 would be 1 year since 2005, which would be the year 2006. And T equals 10 would be 10 years since 2005, which would be the year 2015. Okay, so how do you represent the year 2010? So 2010 is 5 years since 2005, so that would be a T value of 5. So we would say T equals 5. Okay, you're probably familiar with the next part, and I'm going to go through this rather quickly just to save time on the video. Okay, so you're not watching a 40-minute video, just do basic point plotting. Okay, but we use ordered pairs when there's a relationship between two variables. You're most likely familiar with ordered pairs of the form x comma y. Okay, so an ordered pair, x, y. Okay, and there's always parentheses around an ordered pair. Okay, we call x the independent variable and y is the dependent variable. Okay, so if we want to plot these points, okay, so we want to plot the point 3, 5, negative 2, 1, negative 4, negative 2, and so on. Well, you're going to see on my answer key I have everything all done, okay, just to save time. But what you want to look at is, when you look at plotting x's and y's, notice that there are positive x and y values. Okay, so 3, 5, they're both positive, x and y. Negative 2, 1, here x is negative 2, y is 1. Negative 4, negative 2, the x value is negative 4, the y value is negative 2. So when we when we make our grid, okay, so the grid that I have is all done. Okay, it's already drawn on there. But on your paper, if you want to think about where do you put the grid, well, the idea is you want to be able to fit positive and negative x and y values based on the points that I gave you here. Okay, so since these points have positive x and negative x values and positive y and negative y values, we want to put the grid in the center of our given grid. I'm sorry, as I said, put the grid. We want to put our axes in the center of the grid. Okay, so our x-axes, okay, go across the middle here horizontally. The y-axis vertical, okay, now down the middle. Okay, and it sounds a little bit confusing, but anything to the right of the ruler here are positive x values. So anything to the right of the y-axis are positive x values, and that sounds weird. Okay, anything to the right of the y are positive x values because you're going from the center here at 0, 0. As you move to the right, the x value goes to 1 to 2, 3, 4, 5, 6, and so on. Anything to the left of the y-axis will be negative x values. So here's x equals 0 right in the center, and then negative 1, negative 2, negative 3, negative 4, and so on. Conversely, when you look at the y-axis here, anything above the x-axis are positive y values, and anything below the x-axis are negative y values. Okay, so to plot these points, A is at 3, 5, which means the x value is 3, and the y value is 5. So the x value is 3. So here's 0, 0. So the x value is 3. You go over to the right 3, and the y value of 5, you go up 5. Okay, so there's point A. B is at negative 2, 1, so that means the x value is at negative 2. So again, here's an x value of 0 right in the center. So x is negative 2 right here. The y value is 1 if you go up 1. Okay, so you can plot those points okay, on the axes. Okay, and one thing I should mention as far as quadrants go, okay, this isn't something that we go too crazy with in this class, but up here in the upper right is called quadrant 1, and then we go counterclockwise, quadrant 2, and then quadrant 3, and then quadrant 4, IV Roman numeral. Okay, so Roman numeral 1, 2, 3, 4. Now the reason we start with Roman numeral 1 in the upper right-hand corner is because that's where everything is positive, okay, where the x's and y's are both positive, and then they just go counterclockwise to 2, 3, and 4. Okay, so look at plotting those points. Make sure that you understand, like at negative 6, 0, the x value is negative 6, the y value is 0, which means you go negative 6, 1, 2, 3, 4, 5, 6 in the x direction, okay, to the left, and then the y value is 0, which means you go up 0. You can also pay attention to 0, 4, means x is 0, and the y value is 4, so that's this point E right here. Okay, you can also represent ordered pairs other than just saying x, y. You can say the independent variable, comma, dependent variable, input, comma, output, or t, comma, p. Okay, t, comma, p is more if you have like a word problem, where t might be like above here representing the years since 2005. That might be your t value. And then p may represent like a percentage or a profit, something like that. Okay, so the example we get to now, in number 3, suppose P represents the profit in millions of dollars of a business in the year that is T years since 2010. Which is the independent variable? Which is the dependent variable? Okay, well, that's not obvious right away. Okay, but if you think about profit will change as time goes on. So profit will depend on time. So that makes profit the dependent variable and time, or T, the independent variable. Now, if that makes no sense to you, in this class, again, we're just learning the basics right now. In this class, you can generally look at time as being the independent variable, like the x. Okay, and the y, or the dependent variable, will be the other variable. Okay, so in this class, when you see T years since 2010, T is going to be your independent variable, and in this case, P, or the profit, will be your dependent variable. Okay, so how would you represent them as an ordered pair? It'd be T, comma, P. Okay, input, comma, output, or independent, comma, dependent, okay, is T, comma, P. So explain what each ordered pair means. So the point, 0, 3, well here, the input is 0, which means the T value is 0, and the P value is 3. So that means we are 0 years since 2010, and P is the profit of $3 million. So to write that nicely in a sentence, in the year 2010, the profit was $3 million. Okay, now if you need to pause the video because I'm going too fast, feel free to do that. Okay, but again, I don't want to make a 40-minute video, so I'm just trying to keep this as fast as I can. But if you need to pause it, or rewind it. Okay, do whatever you need to do, so you can follow this. Okay, and then the point 1, comma, 5. Now the T value is 1, which means that we are 1 year since 2010. So that'd be the year 2011. The profit was $5 million. Okay, so in 2011, the profit was $5 million. Okay, on the next page, okay, we have the same example. We still have the year and the profit. We're going to write the ordered pairs T, comma, P. And remember, T is the year since 2010. So in 2010, there's $3 million in profit. In 2011, there's $5 million in profit. So again, just writing them as the ordered pairs right here. Okay, now what we're going to do is we're going to graph the ordered pairs, and we're going to label the axes, creating a scattergram. And again, a scattergram is just a fancy way of saying now we have context to our question in a word problem. Okay, so we're just going to call that a scattergram or a scatter plot, okay, meaning the same thing. Okay, now here, when we make our axes, we're not just plotting x's and y's like we did before, where the center of our axes was right in the center of the grid that they gave us. Okay, where we put it right in the center like this. Okay, because these are just x, y points, where we had positive and negative values for x and y. Well, now what we're looking at is, do we have any negative t values? Well, if we're starting at 0 years since 2010, and then going to 1, 2, 3, and so on, there are no negative t values. For the profit, okay, so the profit in millions, those are all positive p values. So when we put our axes on our grid, we only want to use quadrant 1, meaning positive t and p values. So we put the axes, okay, drawn like this in the bottom left. And again, mine is all done. I'm going to go through and explain some things here. But we put our axes in the bottom left, okay, because we only want to have positive t and p values. If we were to put our axes in the middle right here, in the center, we'd be wasting 3/4 of the grid, because we'd only have points plotted up here. Okay, so we put our axes in the appropriate spot. Okay, now we have t, our independent variable, okay, is our horizontal axis. That's the number of years since 2010, so we have that labeled. P is the vertical axis. That's a profit in millions. And then we'll make our tick marks. Well, here, again, this is a pretty basic one to start with. We want to fit from 0 to 1, 2, 3, 4, 5 in there. So we start at 0 years since 2010. And if you said every tick mark was worth 1 year, then that's fine. Okay, so 0, 1, 2, 3, 4, and so on. And then going up the vertical axis for the profit, notice that the lowest profit was 3 million, and then went to 5, and then 7, then 9. So if we fit values in there, if we started at 0 again, okay, so we started at 0 here. And if we just went up by 1 million, then we're not really wasting a lot of space there. Okay, so you going up by $1 million in profit is a pretty good scale to use. Now notice I labeled every other tick mark. Okay, so the first tick mark is worth 1 million, and then 2, 3, 4, 5, 6, and so on. You don't have to label every single tick mark because sometimes it gets really crunched together and it's hard to read. So I just labeled every other one. But notice I stayed consistent. Once I said that first tick mark was worth 1 million, then the next one has to be worth an additional million to get to 2, and then 3, then 4, and so on. So once you start labeling, you be consistent. Okay, so then we plot the points 0, 3, 1, 5, and so on. Okay, so you can plot the points down here. 0, 3 is this point, 1, 5 is this point, 2, 7 is this point, and so on. Okay, and then it asks us, is the data linear? Well, the idea of linear is something we're going to build on throughout the course, or throughout the first several weeks of the course. And it's probably the biggest concept in the course, okay, about is data linear and representing linear equations or linear graphs. Okay, but right now we're going to look at it as being linear. If you were to take a ruler, do all those points lie on that line, meaning represented by the side of that ruler. Okay, so it looks like, yes, this data will be linear, these points will be linear, okay, because all the points, it looks like, would lie on that line. Now, this is something we'll get into, again, in more detail later on, but the idea is this line has an exact pattern. What that pattern is we started at $3 million and then did what? Went up $2 million every 1 year. So that means we go up 2 boxes, which represents $2 million, and to the right 1 box means going to the right 1 year. Notice we keep doing that. Up 2 boxes to the right 1, up 2 boxes to the right 1, or up $2 million to the right 1 year, up $2 million to the right 1 year. That means when that rate of change is always the same like that, that means we're going to have a linear equation or linear graph. Now again, that's something we'll build on later on. But right now, yep, it looks like a line will pass through those points, so it's linear. Okay, assuming the trend continues, use your graph to predict the year when the profit is 13 million. So when is the profit 13 million? Well, profit is a p-value of 13. So it looks like we, up at 13 million, we hit the graph right about here, go straight down, and it looks like MT equals 5. So when t equals 5, that's 5 years since 2010, which would be the year 2015. As an ordered pair, you have to be careful here. Remember, your ordered pairs are t comma p. T is 5, P would be 13. Okay, so the ordered pair would be 5, 13. Okay, and then use a table or graph to write an equation relating the variables t and p, and check your equation for 3, 9. Now this is something we're going to keep building on throughout the course. Okay, and it's kind of tricky to start with. Okay, one thing you want to think about though is we said that the profit depends on the number of years since 2010. So how do we find profit? Well, we know that we started at $3 million. Okay, we can look at the graph or the table and saying in the year 2010 we started at $3 million. Okay, right? And then what did we do every year? Well, as we added 1 year, what happened to the profit? It went up $2 million. Well, when you look at it this way, as to get the profit, we're going to start at 3. Okay, so $3 million, and we add what? Well, we're going to add $2 million every year. So if we added $2 million once, that means we would add $2 million to that original $3 million. If we add $2 million twice, we would be adding $4 million to that original amount of $3 million. If we added $2 million for 5 years, we would add $2 million 5 times to add $10 million to our initial $3 million. Okay, so we're going to add $2 million t times, where t is the number of years since 2010. And essentially, what that's saying is when you look at our graph, or when you look at our table up here, in 2010, from 2011, we added 1 year. What happened to the profit in that 1 year? We added $2 million. In the next year, we added, from 2011 to 2012, we added another year, but we have to add another $2 million. Do the same thing for from 2012 to 13. We had 1 year, we had to add $2 million. So the idea is, if we started at $3 million, that never changed. Okay, so the $3 million, we started with that amount in 2010, but then we have to add $2 million how many times? Well, that depends on how many years you go out since 2010. So if we went to the year 2013, look at it this way. How many times did we add $2 million? 1, 2, 3 times. Well, wouldn't 3 be the number of years since 2010? Okay, so that's where this equation comes from. And again, it's not obvious to figure that out. Okay, but we'll build on that throughout the course. And then if we want to check our equation using the 0.39, so now that we have an equation that represents the profit, then any point that we know is true should work in that equation. Otherwise, that equation wouldn't be the right equation. So we take our 3, 9. So when t is 3, so we put 3 in for t. P is 9, so we put 9 in for p. And then are they equal to each other? Well, yes. Okay, so moving on. Okay, next example we look at is we're given the average price per barrel of crude oil for various years. Okay, so we have our table here. Part A, we're going to rewrite the table as ordered pairs of the form T, A, where T represents the year since 2005, and A represents the average price per barrel of crude oil. And we're going to create a scattergram of T, A. Okay, so rewriting them as ordered pairs. Again, the year since 2005, you got to pay attention there. They give us the first year is 2007, so that means that's a t value of 2. Okay, because they define our variable t to be the year since 2005. Okay, so 2, 73 will be the first ordered pair, and then 3, 99, and so on. Okay, and then we're going to create a scattergram for T, A. And just like in a previous example, notice that there are no negative T values. Okay, so essentially we're going from 2 to 6, or really since 2005, the year 2005 will be a T value of 0. So we want to fit from 0 through 6 for the T values. And then for the average price, okay, the output, the lowest is 62, the highest is 112. So we have to fit those values on a grid. Okay, and again, mine is already done just for the sake of time. but we have the number of years since 2005 as our independent variable, because that's our time, okay, our t-value. Our average price will be going up the side. And then, if we just start at 0, for 0 years since 2005, go up by 1, okay, that's a pretty good scale to use. And then going up the side, again, this is pretty arbitrary, okay, but we want to fit from 62 all the way to 112. So I just went up by 15s. Okay, so we start at 0, that'd be 15, 30, 45, 60, 75, 90, and so on. Okay, if you use a scale of like 20, that would probably work okay. Again, you want to use a value that's fairly convenient and easy to plot the points. Okay, because once you start plotting these points, for example, the first one at 2, 73, well, here's t is 2. That's easy to find. But here we have 60, and then the next tick mark will be actually 75, and then 90. So 73 will be just below this line right here. And that can be a little annoying to try to estimate where those points are. And that's kind of the key here is, and one of the concepts is that you are estimating where to put these points. Okay, it's an educated estimate, but you can kind of have to guess where they are. Okay, so that's a scatter plot or scattergram. Okay, and then notice next to that there's another grid, and it has broken line graph above it. Okay, so this is another concept to look at. Okay, a broken line graph. Okay, what we notice here is when we plotted these points, notice how we're skipping all the values from 0 through 60. Okay, there's a lot of values that we skip there that are part of the graph that we don't even need. Okay, like we don't need any part of this grid. So when something like that happens, we can use what we call a broken line graph. And all you do for that, it's very similar to the first graph, except we can put a couple of tick marks, a little zigzag, okay, right above the 0 on the a-axis, kind of the vertical axis here. And what that does is you can look at it like literally breaking your axes off. Okay, like you broke the axes, and then that allows you to start at whatever value you want. So I just chose to start at 60 because 62 is the next lowest number we need. So I started at 60, and what I could do is rather than go up by 15s like I did over here, I can make a smaller scale going up by 10s. So if I go 60, 70, 80, 90, 100, and so on, what that does is it allows you to make a scale that may be better to use.